Good morning.
Good morning. How are you?
I'm doing fine, and you?
Good, good. Oh, in your class with the technology? Two more minutes. Where is everybody? Lauren.
Good morning.
All right, I'm gonna go ahead. Oh, I've been recording this whole time. I hate it when I do that. I'm gonna go ahead and get started with 6.4. And it's actually, if you'll remember what we did at the end of the day, or on Thursday, some more of that factoring, the three terms with the trinomials that had the number in front of the x squared, where we had to start off by multiplying the outside numbers, and then we made that little T-chart. It's gonna be some more practice on that. Now, it's also gonna kind of relate this factoring to FOIL. Like on number 1, it says decide which is the correct factored form of the given polynomial. Oh, what's happening? Five x squared minus 14x minus 3. And then it's multiple choice, and it says which one of these is the correct form. It's either 5x plus 1, x minus 3, or 5x minus 1, x plus 3. And asks you which one of these is the correct factored form. So one of two things can happen. I can either FOIL both of these to see which one gives me this in the end, or I can factor this using that long method. I'm actually going to do it both ways to show you there is a relationship between the two operations. So I'm going to FOIL both of these first to see which one gives me this in the end. So let's see if I FOIL my first 5x times x gives me 5x squared. My outer 5x times negative 3 gives me negative 15x. My inner positive 1 times x gives me positive 1x. And then my last, positive 1 times negative 3 gives me negative 3. And then these x's in the middle can go together, right? They're same kind of terms. They're both x's. So let's put those together. So I have 5x squared. When I put these together, negative 15x plus 1x does give me negative 14x. And then drop down to minus 3. So this one is the one that if I FOILed it, gives me 5x squared minus 14x minus 3. I'm going to go ahead and do this one just to show you what happens when your signs are wrong, right? Because look at this. If I do 5x times x, there's my 5x squared. But this time my outer gives me positive 15x, right? Because I have 5x times positive 3, which is positive 15x. My inner, negative 1 times x is negative 1x. And my last, negative 1 times positive 3 is negative 3. So I do get the 5x squared and the minus 3. That is right. But look what you get when you combine the x's on this one. I would have 5x squared. 15x minus 1x is positive 14x minus 3. So I needed it to be negative 14x, but it ended up giving me positive 14x. So that's why it's not this one, but it's 5x plus 1 times x minus 3. So that's how important the signs are. Now, I could have, instead of foiling both of those, factored this, the long method, like we learned on Thursday, where we do multiply the outer. 5 times negative 3 gives me negative 15. Now, remember the calculator trick that I told you. Whatever this number is, you can go to your calculator, hit the Y equals button, clear out anything that's in there. Put in this number, -15. Then hit, remember how we did it? We did divided by, and then we'd hit this X button. Then we went down to the second Y equals and typed in the same exact thing right here. So -15 divided by X again, but remember then we put a plus X there. So plus X. Now what we want to do is see the table. So hit second, and then come up here and hit this table button. Okay, remember where you're looking. You are looking in the very last column for this middle number. So I'm looking for -14 in the very last column, and I see it right here. So let's go down to there. So once I see that -14, these are the numbers that I use. +1 and -15. That's what I'm going to put in my little chart. +1, -15. Now remember, I'm going to make some fractions, and this is going to be the denominator of your fraction. So I put them under 5x. Then you reduce your fractions. 1/5 doesn't reduce, right? That's in simplest form. But -15 over 5 does reduce, because -15 divided by 5 is -3. That's where your answers come from. Bottom and top, 5x plus 1. Using the reduced form, so it'll be x minus 3. So see, that would also, these are the same thing, right? That's the relationship. That's what you get if you FOIL. This was the correct one. It's the one that got you this trinomial. Or I could have just factored this trinomial and gotten the right answer to pick. Okay, let's look at number 2. Number 2 says decide which one is the correct one again. I've got 6y squared plus 49y minus 45. This time, instead of just giving us 2 things to choose from, it gives us 4 things to choose from. So instead of foiling all 4 of those, until I hopefully get this, what if it's the last one? That could take you quite a while. So why not just factor it and then pick which one of these you end up with? Okay, my numbers are going to be out of control on this one, but that's fine because we have the calculator. So let's factor this. Multiply my outside, 6 times -45. I'll just push that in my calculator, right? 6 times -45 gives me -270. So remember, what I'm doing now is looking for numbers that multiply to give me -270. There's going to be a lot of ways to do that. And at the same time, add to 49. But I have my calculator. Remember, it does that work for you. So just go to your y equals and clear it out again. This is the number. -270 is the number I put in my calculator. So -270. Divide that by x. And then do it again. -270 divided by x and then plus x. So remember, double check this always. Make sure those two numbers are the same. Divided by x, and that the bottom one has a plus x. Then hit second table. In your last column, you are looking for positive 49. So if I'm looking at this, my negatives are going this way. It looks like my positives go this way. So let's go down until I see a 49 in this last column. Oh, there it is. So here's my 49, which means what numbers am I using? 54 and negative 5. Positive 54, negative 5. There's my denominator, right? I'm putting them both over 6y. And reducing. Let's see, does 54 over 6 reduce? If you're not sure, just divide that in your calculator. 54 divided by 6. Okay, so it reduces to 9. So that's going to end up being positive 9. Does negative 5/6 reduce? That doesn't reduce, right? That's in its simplest form. That takes you straight to your answers. Using the reduced version, what's this one going to be? Y plus 9. This one will be 6y minus 5. So now you are just going to the multiple choice and looking for the one. Oh, and this brings up a good point. These can be either way. Okay, I can put these in either way, like this 6y minus 5 could be the front one. And the y plus 9 can be the second one. It doesn't matter which way those are. It's just that there has to be a y with a plus 9 and a 6y with a minus 5. So that's what you're looking for. 6y plus 5. Now I need 6y minus 5. So there's my 6y minus 5 and my y plus 9. So that's why it would be this B one. All right, number 3. Says complete the factoring. I've got 4a squared plus 4ab minus 3b squared. And it tells me that part of the factoring is 2a plus 3b, and it wants me to fill in the rest of it. Now, here's the good news about this. I know that factoring is the opposite of FOIL. So what I need to think about is if these two things are going to multiply and get me back to here, this one times this one, my first is going to have to be 4a squared. So what does that mean this needs to be? If it's going to end up 4a squared, I'm going to have to multiply this 2a times another 2a, right? That's how it would turn into 4a squared. And then my last, this one, times what goes last there is going to have to give me negative 3b squared. So if I've got positive 3, and I've got to multiply it times something that's going to give me negative 3b squared, the sign is going to have to change, right? A positive times a negative is what's going to turn that positive 3b into negative 3. What else is going to have to be here? I've already got the 3. I just need b squared, which means I need b times b, right? Positive 3b times negative b is what's going to give me negative 3b squared. All right, the rest of them are just to factor completely, doing the long method. So we're getting a lot of practice at this. Number 4, you've got 11a squared plus 13a plus 2. And it just says to factor it completely. Now remember, we are always looking for something in common first. Anytime you're factoring, you look for something in common. It's just that these don't all have an A, because that last term doesn't have an A. And none of these numbers divide, they don't all divide by the same thing, except 1, which doesn't help you. So there's not anything to pull out, so we will multiply our outside numbers together. So 11 times positive 2 gives me positive 22. So this is the number that goes into your calculator. Positive 22 goes in your y equals. So go back to y equals and clear it out. And you're putting 22 divided by x. And then go down. Then 22 divided by x plus x. And then second table. What are you looking for in the last column? Whatever that middle number is with that sign. So I'm looking for a positive 13. So just keep going down, down, down until I see a positive. Oh, there it is. 13 right here. So there's my positive 13, which means I'm using positive 11, positive 2. Make your fractions. Here's your denominator, right? 11a. Positive 11 over 11 does reduce to positive 1, right? 11 over 11 is 1. 2 over 11 doesn't reduce. So this one's already in its simplest form. That is where you get your answers. A plus 1. And down here, 11a plus 2. So that's what you would enter as your answers, or as your answer. Right, number 5, same thing. 2x squared plus 7x plus 6. My outer. 2 times positive 6 gives me positive 12. Okay, now you can go to your calculator and put positive 12 divided by x in your y equals. But remember, what is that doing in your calculator? It's just making all the numbers that multiply to get 12. So I'm just going to do that myself over here, since it's a number where I know all the ways to multiply to get 12. Right? So that's what it's going to give you in your calculator, plus a lot of numbers with decimals. Which one of these pairs adds to positive 7? That's the number you would have been looking for in your last column, is positive 7. and then it would have shown you +4, +3. So there's the numbers you're going to use. Put them both over 2x. Let's see, +4/2 does reduce to +2. 3/2 does not reduce. Here's your factors. X +2. Since 3/2 didn't reduce, that's your factor, 2x +3. Now, number 6 has something a little different. We've got, oh no, it didn't. 91m² plus m minus 2. Right, nothing's in common, so I'm going to go ahead and multiply 91 times -2. In my calculator, 91 times -2 gives me -182. These are the numbers that are why you have your calculator to do that work, right? The last time my number was +12 right here. So since I knew all the ways to multiply to get 12, I didn't need my calculator. I just don't want to take the time to figure out all the ways to multiply to get -182. So that's when I go to my y equals and put in the -182. Don't forget your negative down here. -182 divided by x. And then do the same thing. -182 divided by x plus x. Then second table. You're looking for your middle number over here in the third column. What is this number? +1, right? So that's what you're looking for in your last column. So which way do I need to go? There's my negatives. Let's go this way. It looks like my positives are going down if I go up. So let's go this way, and I'm looking for +1. There's my +1, which means the numbers that I'm using are +14 and -13. Make your fractions. There's my denominator, 91m. Now, I don't know if these reduce. So I'm going to put both of those in my calculator. I just go back to my home screen and type in 14 divided by 91. It's going to give me a decimal. Now, if this reduces, I will find it by pushing math and then hit enter twice. So it does reduce. You'll notice that the 14/91, if it gives you that decimal, you turn that decimal into its simplified fraction. So it does reduce to 2/13. So +2/13. I don't know if -13/91 reduces either, so I'm going to try that one. Whoops. So I'll just type it in. -13 divided by, the denominator is 91. There's your decimal. Hit your math, enter twice. So it also reduces to -1/7. Make your you don't want to make a mistake, reduce some fractions, right? Your calculator will do that for you. So it reduced to -1/7. So let's see what this gives me. Bottom, 13m plus 2. This one, 7m minus 1. All right, let's look at number 7. X squared minus 49x plus 18. Okay, I do look for something in common. Let's remind ourselves how to look for that, right? If there's going to be a number that goes into all of them, let's check that. I always look at my smallest number, which is 18, and write out the ways to multiply to get 18. And then I see if any of these also go into all the other ones. I'm just checking it. I'm not sure. Let's see. I start with the biggest one, 18. I don't have to check 18, right? All these numbers go into 18. That's what the list makes up. All the ways to multiply to get 18. So let's see. Does 49 divide by 18? When you put that in your calculator, you get a decimal, right? Which means 49 doesn't divide evenly by 18. Then try 9. Does 49 divide by 9? Again, no, because it gives you a decimal. The next biggest number is the 6. Does 49 divide by 6? Again, decimal. You can do it over and over. It's not going to divide by 3 or 2 either. Everybody divides by 1, but 1 doesn't help you. Okay, so then none of these numbers divide by all the same thing, because not even 49 and 18 divide by the same thing. So you do look for that first, but since that didn't happen, I multiply my outside numbers together. So I have 33 times positive 18. It's definitely something I do in my calculator. It gives me positive 594. So I just multiplied 33 times 18, gave me 594. Now, this is one where I definitely don't want to come over here and write out all the ways to multiply to get 594. It's going to take me all day. So that's why you go to your y equals and clear it. That's the number you put in. So 594 divided by x. Do it again, 594 divided by x again. And then remember, throw in a plus x at the end. So plus x. And then hit second table. What are you looking for in your last column? Negative 49 in your last column. So here's my last column. I'm trying to find negative 49. It looks like my negatives are going the wrong. I need to go this way, right, to get to negative 49. So I'll just go up. There's my negative 49, which means those are the numbers that I'm going to be using, negative 22 and negative 27. Right? That would have taken you all day without this calculator. I'm putting them both over 33x. And then reducing those fractions, right? Your calculator will do that for you too. Just hit second quit. That gets you back to your home screen. So let's see, let's reduce this first fraction. I have negative 22 over 33. Hit enter, there's your crazy decimal. Math, enter that. So that will reduce negative 22 over 33 to negative 2/3. Do the same thing here, negative 27 over positive 33, so negative 27 over 33. There's your weird decimal. Math, enter that one. So that one reduced to negative 9 over 11. And those are where your factors come from. So 3x minus 2, 11x minus 9 are your factors. Right, number 8. Okay, nothing's going to go into all 3 of these, right? Because nothing's going to go into 12 and 13 besides 1. So I'm going to go ahead and multiply my outside numbers together. So I've got 12 times negative 13, which gives me negative 156. So negative 156 is what goes in your y equals. Let's go to your y equals and clear it out. Put a negative 156. Divide that by x and then do the same thing on the second one. Negative 156 divided by x, throw in a plus x. Uh-oh. And then second table, and I'm looking for negative 49 in my last column. Here, let me show you another little trick. If you start getting a bunch of number decimals in this y column, here's another thing that kind of just resets your tables. If you go to second, and then hit this table set. Yeah. Second and then table set. Change this number to a 1. So clear, table start, and put in 1. And then hit second table again. So see, it took, remember how many, all those decimal, every single one of those was a decimal. That kind of just restarts it. After you do this several times, it kind of makes the y's have, there's so many of them. Okay, so this kind of just cleans it up. So now I'm looking for negative 49 in the last column, which is right there, which means I use negative 52 and positive 3. Put them both over 12y. And reduce your fraction. So second quit, to get back to the home screen. If you want to clear it out, clear it out. So what is my fraction? Negative 52 divided by 12. Math, enter twice, so that reduces to negative 13/3. You can put this in your calculator also. The math, enter that. That's going to reduce to positive 1/4. And then there's your factors. 3y minus 13 and 4y plus 1. Right, 2 more of these before we jump to 6.5. $25v squared plus 19v plus 4. All right. Nothing's in common, right? Nothing goes into 25, 19, and 4. I'm going to multiply my outside numbers. 25 times positive 4 is positive 100. 100's got a lot of ways to multiply to get it. So let's go to our y equals and have the calculator do it for us. All right, so 100 is my number. So 100 divided by x. Same thing, 100 divided by x plus x. And then make your table. So second table, what are you looking for? Positive 19. So I'm looking at my last column. There's 21, 20, another 20, really 20. So look what just happened. Started going the other way. So what that's telling me is it skipped the 19. Right? It started going the other way. And if I wanted to clean it up, again, you'll notice I'm starting to get a bunch of decimals in this Y1 column. How you clean that up is you hit second table set. Why do I keep doing that? Second table set, and then start this at positive 1. So clear that and tell it to start your table at 1. And then go back to the table. So second table. So see, it kind of cleaned up this. So you don't have so much to look at. So I'll be looking for 19 over here. So it got to 20. And then instead of going down more, it started going back up. So there is not a 19 in that one, which just means what? If I don't have the numbers that complete my chart, that just means this one is prime. There are no multiples, or there are no factors of 100 that add to 19. Okay, every single one of these has been multiple choice. You either click A and type in your answer, or B, it is prime, because there are no numbers that do what we need them to do. So number 9 was prime. And the last one. X squared plus 114 x plus 26. The first thing I'm noticing is that all 3 of these terms are even, which means 2 goes into all of them. Then I'm curious if something higher than 2 goes into all of them. So let's check this. Use your smallest number. So I am going to be able to pull something out of this one. I'm going to do my smallest number, 26 times 1, 13 times 2. Those are all the ways to multiply to get 26. So let's start and see if any of the other numbers divide? I know they all divide by 2, right? Because they're all even. All even numbers divide evenly by 2. But I need to make sure that one of these higher numbers doesn't go into those also. So let's check the 26. But if you divide 40, is 40 going to divide evenly by 26? No. So 26 doesn't go into all of them. Try the 13. Does 40 divide evenly by 13? No. But they all divide evenly by 2, which means this one has a greatest common factor that I need to pull out. So I'm going to pull out the 2 and put in parentheses what is left. Remember how to find that. Whatever you pull out, that's what you divide by to put in parentheses what is left. So let's see, 40 divided by 2, so that's going to give me 20x squared plus 114 divided by 2. What is that, 57x plus 26 divided by 2 gives me 13. So this one did have a greatest common factor, so I pulled it out. I need to see if what's left inside here factors again, just using what we've been doing. So let's multiply my outside numbers. 20 times 13. So that gives me positive 260. I don't want to mess with 260, so let's go to our y equals and put it in. So 260 divided by x, and go down to the second one, 260 divided by x plus x. Second table. What am I looking for in my last column? Here's what I'm factoring, right? I don't go back up here. I'm factoring here now. So I'm looking for positive 57 in my last column. So there's my positive 57, which means I'm going to use positive 52 and positive 5. So since it does have numbers that do that, that automatically means this factors again. So what's going to be the denominator of both of these? Here's what I'm dealing with. So it's going to be 20x. And then reduce your fractions. So let's see, positive 52. So 52 divided by 20. I'm just doing this on the regular home screen, right? Here's your weird decimal. So math, enter that. So it reduces to 13 over 5. So positive 13 over 5. If you want to put this one in your calculator, that's fine. That's going to reduce to positive 1/4. There's your factors. So this one will be 5x plus 13. This one will be 4x plus 1. Now, remember what happened. What was the first thing that you did when you were factoring? You pulled out a 2, which means that is part of your answer. This 2 that you pulled out goes in front of those other 2 factors. Okay, I am going to cover 6.5 also. It won't be too much. So let's talk about the different kind of factorings that we've done so far, because we're about to add the last kind of factoring that we're going to do. So the very first thing that we talked about in 6.1 was the greatest common factor, which we actually had one on that last problem. That's when they all have something in common and you pull it out. So that was the first type of factoring that we talked about, greatest common factor. And that's what you always look for first. The second thing that we talked about was factoring for terms by grouping. That was also in 6.1. Now this one, the clue that it was this type of factoring, it was that, first of all, that there were 4 terms and nothing was in common with all 4 of them. I couldn't pull anything out. So we put them in those 2 smaller groups. So that was the second type. The third type were, there's 2 different types of trinomials that we've talked about. So it's kind of like the good ones and the bad ones, the short method and the long method. They're both trinomials, which means they both have 3 terms. The difference between the 2 are sometimes your trinomial just starts with an x squared. Okay, you don't even see the 1 in front of it. It'll just say x squared. When that happens, what did we do? Well, we just jumped straight to x and x because that's the only way to get x squared. The other trinomials, which we've been doing all day today and Thursday, were the trinomials that started with a number other than 1x squared. Any other number, whether it was 2x squared, 5x squared, 6x squared. That's what tells you that it's the longer method, where you have to do exactly what we've been doing all day, which starts off by multiplying your outside numbers, making your t-chart. That's that kind of trinomial. The very last kind of factoring that we're going to talk about today is, where did I put it? Let me go over here. Difference of perfect squares. Okay? Here's what tells you if it's a difference of perfect squares. First of all, there's only 2 terms. So it's not a trinomial. It can't be factoring by grouping because there's not 4 terms. So there are 2 terms. They have to have a minus in between them. That's why it's called the difference, right? Difference means you're subtracting. And the 2 terms have to be what are called perfect squares. That means they have to have factors that multiply to get them that are the same number. Perfect square numbers are 1, 4, 9, 16, 25, 36, 49. All right, there's your first 10 perfect squares. They go on forever. Here's what makes them a perfect square. 1, you can get 1 by multiplying the same number together. 1 times 1. You can get 4 by multiplying the same number together, right? 2 times 2. Same thing for all of these numbers. I can get 36 by multiplying the same number together. 6 times 6. Every single one of these fall into that category, right? I can do 100. 10 times 10. That's why they are called perfect squares. So 3 things have to happen for perfect squares. There has to be 2 terms. There has to be a minus in the middle. And the front term and the back term have to be perfect squares. They're not always letters. Sometimes, I mean numbers, sometimes they're letters, but x squared is a perfect square because just like these, I can use the same thing to multiply to get x squared. So let's look at some of these. Number 1. You have b squared minus 49. So let's do our checklist. 2 terms, yes. Minus in the middle, yes. Are these both perfect squares? Or in other words, can I use the same thing twice to multiply to get both of those? Yeah, I can use b times b for b squared. And I can use 7 times 7 for 49. So they are both perfect squares. So this is how you factor. What goes in the front is the same thing you would multiply together to get this first term. So it would be b times b. What goes at the back of each of the factors is that same number that multiplies together to give you 49. So that's where we put 7 and 7. Now, here's the good thing about difference of perfect squares. Your signs are always one positive, one negative, and it doesn't even matter which one comes first. So b plus 7, b minus 7 is the factoring of that. All right, let's look at number 2. R squared minus 121. Do your check. 2 terms, yes. Minus in the middle, yes. R squared is a perfect square, right? I can use R and R. If you're not sure about the number, here's how you would check it. It would, if you do square root, let's see, where's my square root button? It's right here. But see how it's blue? So if I need to I need to do second square root, put in the number right there. So I'm putting in 121. If I'm not sure if that's a perfect square, just type it in, square root of 121, and hit enter. If that's a decimal, this is not a perfect square. This one's not a decimal. That's telling me that 11 times 11 is 121. So 121 is a perfect square. So I can factor this. R and R for R squared. We just found 11 and 11 gives me 121. 1 plus 1 minus. Right, number 3. B squared minus 18. I'm going to do 3 and 4 together. A squared plus 16. So do your checks. 2 terms, yes. Minus in the middle, yes. B squared is a perfect square. I can use B and B. But what about 18? If I did my check and did second square root and put the 18 here and hit enter, it gives me a decimal. That means 18 is not a perfect square. So that one messes up my checks, which means this one is prime. When you do your checks here, 2 terms, yes. A squared is a perfect square because I can use A and A. 16 is a perfect square because I can use 4 and 4. But what's in the middle? A plus. It has to be a minus. So that's why that one is prime. So 3 and 4 were both prime for different reasons. They just didn't satisfy my checks. Number 5, 192c squared minus 75. So first things first, it's 2 terms, it's got my minus. Neither one of those are perfect squares, but then remember what you always look for first. This one makes me a little nervous because those numbers are so high, I'm thinking there's probably something in common. I'm going to use my small number, 75 and 1. I'm thinking somewhere in there, probably one of those numbers also goes into 192, which means I'm going to be able to pull it out. Okay, start with your high. It's not going to be 75, right? 75, you can try it. So I'm trying all my numbers to see if any of those go into 192. So I would just be typing them all in. 192, divide that by 75 decimal. So that's not it. Go to your next highest number. So 25. Still a decimal, so it's not 25. Do the same thing with 15. 192 divided by 15. Still a decimal. I'm still pretty confident. 192 divided by 5. Still a decimal. My last chance would be the 3. 192 divided by 3. Not a decimal. Which means 3 goes into 75 and 192. So what does that tell you? You need to do first, pull out the 3. So let's see, if I divide those by 3, 192 divided by 3, I just did that. It was the last thing I did in my calculator. So that gives me 64c squared minus 75 divided by 3 is 25. So we pulled out a 3. Now let's see what happens here. So let's see, is 64 a perfect square? Yeah, I could use 8 and 8. So is c squared, right? You can use c and c. So to get 64c squared, what can I use? 8c, 8c. What about 25? Yeah, I can use 5 and 5. So I bring down my 3, and then what's left in here is a difference of perfect squares. To get 64c squared, I will use 8c, 8c. To use 25, I'll use 5 and 5. And what do you know about the signs? Plus, minus. Right, number 6. First thing I notice is that there's a plus in the middle, so it's not a difference of squares. That doesn't mean that you can't factor it. If you can pull out a greatest common factor, you can factor this, right? There is a number that will go into both of these. So there is a type of factoring I can do here. So let's see, I'll use the 36 and see what I can pull out. Yuck. All that goes into 36. I need to find the highest number that also goes into 64. 36 doesn't. Let's see, does 18, if you divide 64 divided by 18, it gives you 3.5555 something. 12, let's see if 64 divides by 12. No, still gives me a decimal. It doesn't divide by 9, it doesn't divide by 6, but what happens when you try to divide it by 4? 64 divided by 4 does give me a whole number. It's not a decimal, which means 4 goes into 36 and 64. So what does that tell you? You need to pull it out. And then put in parentheses what's left. 64 divided by 4, that gave me 16x squared. Plus 36 divided by 4 gives me 9. So these are still perfect squares, but there's a plus in the middle. I've already pulled out the most they have in common. So that's just as far as that one goes. It has a greatest common factor, which means it's not prime. You did something. You did change it by pulling out the 4. Right, number 7. C to the 4th minus 196. 2 terms? Yes. Minus in the middle? Yes. C to the 4th is a perfect square, right? If you can use the same thing 2 times and multiply to get C to the 4th, then it is a perfect square. What can you use to get C to the 4th? If these have to be the same and multiply to get that, I can use C squared, right? I'm not sure about 196. How do I check it? Do the square root of it. So second square root, put your 196 in there. If it gives you a whole number, that's the number you're using, 14 and 14. One plus, one minus. Now, when we get to number 8, it starts being a different kind in difference of squares, and you should be able to tell that because there's not 2 terms. If there's not 2 terms, then it's not a difference of squares. There's 3 terms. Now, that means, remember when we just wrote out those 5 factoring methods? Numbers 3 and 4 were both trinomials, right? Which is what this is, right? There's 3 terms, which makes it a trinomial. There was either the kind that starts off with just a squared, which is what this is, which makes it the good kind, the short method, or there would be a number in front of a squared, which is the long method. That's what tells you you have to multiply your outside numbers together, is if you see a number right here. So since I don't, I know I can automatically jump to A and A. Since I didn't multiply my outside numbers, this is the number you would put in your y equals. So if you went to your y equals and cleared it out, 16 is the number that you would put in there. 16 divided by x. 16 divided by x plus x. So we do the same thing. It's just that I use this number. And then hit second table, looking for your middle number, which is positive 8 in that last column, which tells me I need to use positive 4, positive 4. They just go right there. You jump straight to your parentheses. You skip the whole t-chart altogether. Multiply to get 16 and add to get 8. Number 9. W squared minus 12W plus 36. Again, 3 terms, so it's a trinomial. It's a good one though, because there's not a number, or there is, it's just a 1, which means I jump straight to WW. That's the only way to multiply to get W squared. 36 is what you put in your Y equals. Go to your Y equals again, clear it out. Put in the 36 divided by X. 36 divided by X plus X. And then do your table, second table. I'm looking for what? Be careful with your sign. I'm looking for a negative 12 this time. So just go up until I get into, there's my negatives. I'm looking for negative 12. Oh, there's negative 12 right there, which means I use negative 6, negative 6. And I go straight in to your factors. Number 10. We're getting there. X squared minus 14x plus 196. Again, trinomial, but it's a good one, so I'll just start off with x and x. 196 is who's going in my Y equals. So same method. Second table, I am looking for negative 14 in my last column. So it looks like my negatives are going in the right direction, going up. Okay, so it's happening again. I'm getting too much information. So I'm going to reset my table. So second table set started at 1. And then go back to your table. So second table. So it cleaned it up a little bit. What am I looking for in my last column? I already forgot. Negative 14. So it looks like I need to go down, right? My numbers are going down this way. Golly, it's already doing it again. Oh, what happened?
It's gonna be prime.
Wow, you're right. It is prime. I thought I was going to be able to do it. So this one, you're right. It doesn't have this, right? It just misses it. It skips it. It doesn't have it. So that's why you are absolutely correct. That one is prime. Okay, 4 more. We can make it. Number 11, 2x squared plus 24x plus 72. First things first, what do you always look for first? And I can tell anytime they're all even, they're going to divide by that 2. So that overshadows every other kind of factoring. If there is a common factor, you have to pull it out. The good news is 2 is the only thing that's going to go into 2. It also goes into 24 and 72. So you need to pull that 2 out. I look for x's in common too, right? But this 72 doesn't have an x on it. So I can't pull out any x's, just the 2. Which actually helps us a lot. Because if I pulled the 2 out of this first term, what does it turn it into? Just x squared plus 24 divided by 2 gives me 12x plus 72 divided by 2 gives me 36. Now, it started off looking like the long kind of trinomial, right? Since there was a number in front of x squared. But now that I pulled that 2 out, now it is just x squared. So now it is the good kind of trinomial because it jumps straight to x and x. This 2 does come down. So in your calculator, you would put 36 in the y equals and look for 12. So what does that mean? I'm looking for ways to multiply to get 36. And there's a lot of them. And the pair also has to add to 12. So that's why I'm using positive 6 and positive 6. Right, number 12. All right, we're going to do 12. We've got 8y to the third minus 24y squared plus 18y. Now, a clue that there is definitely a greatest common factor is I see everybody's got y's. So I know something's coming out. I also see that I may be able to pull out some numbers. So let's use the 8 since it's the smallest. And there's not that many ways to multiply to get 8, so that's good. Let's see, do they all divide by 8? I know 8 does. 24 divides by 8 because you get 3, but 18 does not divide by 8. Let's see, these both also divide by 4, but 18 doesn't divide by 4. So the only thing that they're all going to divide evenly by is that 2. And like I said, I can also pull a y out of all of those. So I pull a 2y out and put in parentheses what is left. So let's see, 8 divided by 2 gives me 4. I had y to the third, but I took one of them out. So now all I have left is y squared. Minus 24 divided by 2 gives me 12. I had y squared, but I took a y out. All I'm going to have left is the y. Plus, your 18 divided by 2 gives you 9. I had a y, but I pulled it out. So all I'm left with there is that positive 9. So I pulled out the 2y, but I need to check, does what's left inside those parentheses factor some more? So even though I pulled out the 2, I'm still left with a number in front of the y squared that's not a 1. That's what tells you it's the long trinomial method. So I've got to multiply my outside numbers. Positive 4 times positive 9 gives me positive 36. That's the number that's going in your y equals, right? That's what makes it the long method and not the good method. So positive 36 goes in your y equals. So 36 divided by x. Then do it again. 36 divided by x, toss in a plus x. Then hit your table. Second table, I am looking for negative 12 in my last column. Yep. Oh, there it is. I just kept going until I got to it. So there's my negative 12, which means what am I using? Negative 6 and negative 6. Put these both over 4y. them. Let's see, negative 6 over 4 does reduce. If you wanted to do it in your calculator, you could. It reduces to negative 3 over 2. Well, this is the same exact fraction as this, so it's going to also reduce to negative 3 over 2. To y minus 3. And your other factor is also 2y minus 3. Now remember, what did you do first? That is part of your answer. You pulled out a 2y right there, right? So it is part of your answer. Okay, so I know that was long, but we did get through 2 sections today. So 6.4 and 6.5 were covered today. We will do 5.8, I think it's 5.8, on Thursday to round out this week.